My first step is to work out fg of a and gf of a separately. Working out fg of a. As I've got a composite function, i.e. two letters outside the bracket, my first step is add an extra pair of brackets. I always work inside, then out. Therefore, leaving the outside function alone, in this case f, on the inside, I have to first of all work out g of a. Well, g of a means substituting to the function of g. Every time I see x, I'm now substituting the value for a. Therefore, on the right-hand side, instead of having x squared, x is now a, so x squared will become a squared. And I've still got plus 5 on the end. Whatever I get, that now becomes the input for the outside function. So now substituting to the function f, every time I see x, I now substitute x to be a squared plus 5. Here on the right-hand side, I've got 2x. Well, 2x in algebra means 2 multiplied by x. Therefore, I'm going to have a 2. As x is a squared plus 5, as I've got two terms, I'm going to place that inside single brackets. And I've still got the negative 1 on the outside. Expanding my single bracket, whatever's outside, I multiply by each term directly inside. Here, 2 times a squared will give us 2a squared, and 2 times 5 gives us 10. I've still got the negative 1 outside. Collecting like terms, I've got 2a squared, and no other term ending in a squared, so I write that down. And I've got 10 subtract 1, which gives us 9. Now working out the right-hand side, in this case, gf of a. Once again, as I've got a composite function, i.e. two letters outside the bracket, I'm going to start by adding an extra pair of brackets. I always work inside, then out. So leaving the function on the outside alone, in this case g, on the inside, I have to work out f of a. Well, f of a, as the name suggests, means substituting to the function of f. Every time I see x, I'm now substituting the letter a. So on the right-hand side, 2x in algebra, if x is now a, will become 2a. And I've still got negative 1 on the inside. Whatever I get, that now becomes the input for my outside function. So 2a minus 1, I'm going to substitute into the function of g. So every time I see x, I'm now substituting x to be 2a minus 1. So therefore, on the right-hand side, in algebra, I know x squared means x multiplied by itself. If x is now 2a minus 1, therefore x squared will be 2a minus 1 multiplied by itself, i.e. double brackets. And I've still got the plus 5 that I must place on the end. Expanding my double brackets, I know that 2a multiplied by 2a will give us 4a squared. I know that 2a multiplied by negative 1 will give us negative 2a. I know negative 1 multiplied by 2a will give us negative 2a. And negative 1 times negative 1, and negative times negative gives us a positive, so plus 1. And I've still got the plus 5 on the outside. Collecting like terms, I've got 4a squared and no other term ending in a squared. So I'm going to write that down. Collecting my single letters of a. In this case, I've got negative 2a, subtracting another 2a. They're like terms as they both end in single a. So negative 2 take away another 2 means I get simplified down to negative 4 lots of a. And my number terms, here 1 add 5 simplifies to give us plus 6. As we are given that fg of a is equal to gf of a, well, I've worked out fg of a to be 2a squared plus 9. And I've worked out gf of a comes out to be 4a squared minus 4a plus 6. Therefore, 2a squared plus 9 must equal to 4a squared minus 4a plus 6. As I'm asked to show that the quadratic equals to 0, I've got more positive a squared on the right, so I'm going to bring all my terms to the right by doing the opposite. The opposite, add 2a squared to bring it to the right, we subtract 2a squared from both sides. And the opposite, add 9, will be subtract 9 from both sides. On the left-hand side, 2a squared take away 2a squared will cancel, and 9 take away 9 will cancel, which will leave us at 0 on the left-hand side. On the right-hand side, 4 lots of a squared, subtract 2 lots of a squared, will simplify to give us 2a squared. I've still got negative 4a, and 6 subtract 9 gives us negative 3. Having the 0 on the left-hand side is the same as having the 0 on the right-hand side. Hence, I can rewrite my quadratic as being 2a squared minus 4a minus 3 equals to 0.
Does this make sense? What next?